Conjugate acid-base direction of reaction. You were given these problems. You are asked to give the structures of the conjugate base and conjugate acid that will likely result from the given reactants. So these are the given reactants. To answer the questions, we need to be guided by this table. This is table 2.3 from your book. Let us again examine the arrangement in this table. The acids are arranged such that if we go down, the acids become stronger. Let us examine the pKa values. As we go down, the values become smaller. So what does it mean? That if the acid is a stronger acid, its pKa value is small. If the acid is a weaker acid, its pKa value is big. Then we move to the rightmost side. This is now about the conjugate base of the acids. Okay, remember the definition of conjugate base? This is what is left behind when a proton is removed from the acid. So if we remove this proton from ethanol, you obtain, this is now the conjugate base of ethanol. This is called ethoxide. Okay, so these are all the conjugate bases of the acid on the left side. Take note of the trend. As we go down, the conjugate base become weaker. Okay, so what does it mean? If your acid is a weaker acid, the conjugate base is a stronger conjugate base. If the acid is a stronger acid, the conjugate base is weaker. Again, talking about the pKa values in the earlier table, these pKa values are useful for predicting whether a given acid-base reaction will take place, because the proton or hydrogen ion will always go from the stronger acid to the stronger base. That is, an acid will donate a proton to the conjugate base of a weaker acid, and the conjugate base of a weaker acid will remove a proton from the stronger acid. Okay, so from the first question, it's about ethanol and HCN. Okay, which is the stronger acid? It's the HCN or hydrocyanic acid. And ethanol is the weaker acid, but its conjugate base is a stronger conjugate base. Stronger ethoxide is stronger than cyanide ion. So which one will become the proton donor? It's the stronger acid, hydrocyanic acid, donating a proton to ethanol. So this is going to be the reaction. The proton from hydrocyanic acid will be donated to ethanol, so the conjugate base will be cyanide, and this is the structure of the conjugate acid, which is the protonated ethanol. Next question is about acetic acid and dihydrogen phosphate ion. Which is the stronger acid? It's the acetic acid. So this becomes the proton donor. So it donates a proton to dihydrogen phosphate ion. So the reaction will be acetic acid donating a proton to the dihydrogen phosphate, And so this becomes the acetate becomes the conjugate base, and the conjugate acid is phosphoric acid. Moving to the next, it's between water and ethanol. Which is the stronger acid? It's water. So it's likely to become the proton donor, donating a proton to ethanol. And this is the reaction. Water will donate a proton to ethanol, leaving behind the hydroxide. And the conjugate acid is a protonated ethanol. The next will be between acetic acid and phosphoric acid. Going back to the table, acetic acid and phosphoric acid. Phosphoric acid is the stronger acid, so it becomes the proton donor. And this is going to be the reaction. So phosphoric acid will become the proton donor, and what is left behind is the conjugate base, dihydrogen phosphate. And the conjugate acid is the protonated acetic acid. Last question is about acetic acid and ethanol. Which is the stronger acid? Acetic acid. So this becomes the proton donor. And the reaction will become acetic acid donating a proton. So it leaves behind the acetate as the conjugate base, and the conjugate acid is the protonated ethanol.